Hi, my name is Ashim Chakravarti. This video is an attempt to show you how exactly machine learning works. For that reason, I like to execute a pattern classification task on a microcontroller-based electro-optic assembly. As you already can see, the software control of this assembly is written in LabVIEW. Here, the classification process follows a simple machine learning principle called perceptron. In this program, I am trying to classify three patterns from a Boolean logic gate, AND or OR. Therefore, these two inputs, I1 and I2 of this perceptron model, can have values at a time 1, 0, 0, 1, and 1, 1. Also to remind you that this is a single output perceptron model. In the input lines, W1 and W2 represent the signal strengths, also call them as weights. Just like a synapse in our brain, we would like them to adapt during an operation. The weighted sum of these inputs will be our output, and that will be compared against a threshold. Now in a classification process, weights will be adjusted by a learning rate rho amount. Now in that process, suppose output of a pattern 1, 0 is staying below the threshold. However, in actual we want that output to be above the threshold. In that scenario, the weights will be raised by a rho multiplied by inputs 1, 0. This update fed into the input N via this global feedback signal. This will allow the next incoming patterns 0, 1 to see the newly adjusted weights. The output of that pattern will be evaluated afterwards accordingly. This process will be repeated in a recurring manner until the desired classification of all the patterns is found. Before pursuing this perceptron model, I need to characterize these weights first. Ideally, I want these weights to be stable, repeatable, reproducible, and must have a dynamic range to work with. In this program tab, among these two graph indicators, this left window displays dynamic weight update as x1 and x2. As you can see, x1 and x2 are the outcome of the product between the inputs and the weights. This other indicator here shows complete weight and threshold profiles against a timeline. The complete weight profiles are the range of x1 and x2 values as when these weights are raised and lowered sequentially. Although I would like this threshold to be a constant, still dynamic behavior of it will be tested along with these weights. Now in this Age Static tab, you are seeing an exterior image of the classifier. Here this white box is my pattern classifier and that has the hardware in it. I'll talk about the hardware separately in each video program tab. In the hardware of this perceptron, these two lasers are I1 and I2 input providers. They are discretely controlled by this mega board via these two digital to analog converter cards. The change in the resistor values on these deck cards will change the outgoing intensities from these two lasers. Hence, they will assist in adapting weights in the classifier. The third laser is set to be the threshold provider and hence will throw consistently a constant intensity. Finally, laser intensities will be collected on these three phototransistors and used for the computation later on. After describing objects in the front panel, now let me quickly go over the main block diagram behind this classifier. To update register values on the deck cards, this wait program runs a while loop. Inside this loop, 5 programs are running in a stack sequence. First program is to show hardware update during an operation through a webcam. Second program addresses two digital I/O lines from the Mega to make lasers turn on or off. Third program runs deck cards as they receive data from the Mega through a I2C line. Here V is an array that has a data range from 1650 to 2700 and back to 1650 with a step of 10. Fourth program runs 3 phototransistors to receive laser intensities. Finally, fifth program reads laser intensities from these phototransistors and updates in the front panel. Also, these signals are saved into the computer. Before I talk about the block diagram of the wait program, Now let me demonstrate this part of the classifier. First, I will put both lasers at high 1 and 1. As I run this program, you can see recorded laser intensities in red and green curves representing x1 and x2 are rising, while threshold white line stays more or less constant. We can verify this by looking at the hardware directly through the webcam. For that, let me switch to the H-Video tab now. You can clearly see outgoing laser intensities from both lasers are rising as resistor values on DAC cards are changing. Again, as the DAC value is lowering now, laser intensity also starts declining. I go back again to the H-Video tab to show it. Finally, you are seeing the weight and the threshold profiles in this weight profile window. If we follow this red curve, I must say weights are stable and reversible. Again, if I run this software multiple times and do not change external conditions, then weights are reproducible within a 2% tolerance factor. The perceptron program actually runs a state machine in LabVIEW. In this state machine has 3 subprograms consisting pattern, wtrain, and compare. In the pattern state program, lasers receive inputs according to a pattern from a Boolean logic gate. At the wtrain program, lasers are addressed by megaboard plus DAC cards. Phototransistors are also tracked here for collecting laser intensities. These transistor data are used in the compare program to evaluate a pattern output. Later, this output is compared with the threshold for the weight update. This same program also updates the input pattern number. Thus, this state machine regularly updates all patterns from AND/OR gate until a complete classification is found. Now running this perceptron for the AND gate, you can see these inputs I1 and I2 are updating as according to the patterns in the AND gate. Also, this pattern indicator is indicating that. Perhaps you also noticed that these weights are updating as time evolves. This means that weight training is ongoing. We can verify same thing from the hardware. Let me go to the H-Video tab now. So perhaps you noticed that the right laser is on and left laser is off sometimes. That is my first Boolean logic pattern. Next, the left laser is on but right laser is off. That is my second Boolean logic pattern. And thirdly, both lasers are on, and that is my third Boolean logic pattern. If we wait for some time, then you will notice that the laser intensities are getting brighter and brighter. This also indicates that the weight training is ongoing. This also means that these DAC cards are at higher resistive values, and thereby these lasers are throwing higher intensities collected by these two phototransistors. We will wait to see that. As it is clear now that laser intensities are higher compared to before, now let me go to the perceptron tab now. So you are seeing in this perceptron learning window, there are two curves. One is white curve and another is red curve. This white curve is for the threshold line, and the red curve is for all the patterns that in the AND gate, and their output is evaluated here in this red curve. So if we wait for some time, then you will notice that this red curve is trying to catch up this white curve. This is logical. In AND gate, the first two patterns will stay below the threshold line, and the third pattern will go above the threshold line. So that is what my classification process is about. So because of this third pattern, these weights are getting higher and higher in the weight training process. So we'll wait to see that from this window. So you perhaps noticed that this red curve is coming near to the white curve. This means we are approaching near to an end of classification process. So you can see the third pattern is above the threshold line now. So, and also you can see that weights are locked, which means my classification process is done. This right window dictates complete weight training process from the beginning to an end. So in this window you can see that weights are getting higher and higher, thereby it trying to approach the threshold line. In the threshold line there is this oscillations because when both lasers are on there will be different current draw compared to single laser is on. Now if I rerun the same program again, then you won't see the weight update. So let me rerun this program. Since already the classification is done, so weight update won't be necessary, or the perceptron program will not do that. So this is complete classification by a machine learning approach. Let me stop this program now. Now if I want to run for the OR-CAD, the same perceptron model, then you will see these two weights, these two patterns will go above the threshold line as well. And that will make all the three patterns above the threshold line and leaving none below the threshold line. That is my OR-CAD learning. I hope you enjoyed this video. Thank you for watching.